let's review transformations. So remember, a translation is just a slide. It's where we're moving it left or right and up or down. And a reflection is a flip. Remember, that's where we are reflecting it over a line. And a rotation is a turn. Remember, that's where we are turning it. I didn't turn that properly, but you get the idea. A dilation is an enlargement or a reduction. So that's where we're making it bigger or smaller. And compositions are, what word did I want to go here? Compositions are a multiple transformations. In isometry, the transformation that keeps same size and shape. And these are our rigid transformations. I don't think we use that word rigid. And remember, this is our translation, our reflection, and our rotations. This is not our dilations. So if you're asked about isometry or rigid transformations, we're talking about these three and not the dilations. All right, let's go ahead and write down, so we'll have it handy, our counterclockwise rotations. So your typical x to y is going to go to negative yx for 90 degrees counterclockwise. And your 180, doesn't matter which way you're going, counterclockwise or clockwise, it's going to be negative x, negative y. And counterclockwise 270 is y, negative x. All right, let's look at some of these. So translate the point 2, 0 by the rule 2x plus 2y minus 4. Okay, two ways to do this. I could draw a picture, plot my point, it's 2, 0, and then move it and then figure out where it lands. Or I can take the point and I can add 2 to the x and subtract 4 from the y, and that gives me my new point of 4, negative 4. And that's it. All right, rotate D, E, F, G 180 counterclockwise. So this one wants all of the points, negative 3, 2, E, negative 4, 1, F, negative 2, negative 2, G, negative 1, negative 1. Counterclockwise. I'm going to go to that front. We're going to take the opposite sign of the x and opposite sign of the y. And that's all we're going to do to get opposite x, opposite y, the new coordinates. So opposite. So that negative becomes positive. This positive becomes negative. And G at 1, 1. That's it. Oh, G with a little, because it's the new image. All right, the vertices of this triangle are at A, B, C. Name the vertices of the image reflected over the x-axis. So I am going to actually draw a picture for this one. 2, 3, 4. 1, 2. There's A. And 1, 2, 3, 4. 3, 4, 5, 6, 7. B. 5, 1. Is it? Let's see. Big triangle. Okay. So now we want to reflect that over the x-axis, this one right here. So A is going to stay at -4 and go to -2. B is going to stay at 4 and go down to -7. C is going to stay at 5 and go to -1. See, here it is. Very not done well, but reflected over the x-axis. So you can see that your x values are going to stay the same and your y's are going to change signs. I like to draw my picture just to make sure I am reflecting over the right axis and keep those rules proper. All right. State whether the dilation is a reduction or an enlargement and the scale factor. So let's look at this. We are given triangle DEF. I know that this is the pre-image because it's the letters don't have any marks next to them. And then this triangle DEF, this is the image. It got smaller. So we've got a reduction. I'm going to pick point. Let's do E. So E is at 1, 2, 3, 4, 5, 6, 0. And this E is at 1, 2, 0. So remember, I'm putting image over pre-image, image over pre-image, and I'm going to reduce that fraction to 1/3, and this is our scale factor. All right, let me know if you have any transformation questions.